Hello and welcome back to KeenOnMaths. In this episode we're going to be doing a deep dive into one particular topic. So unlike going through the past papers, we're just going to be looking at one topic, and that topic today is simultaneous equations. Now I think this is a really good topic for a lot of reasons. The main reason is it covers so many algebra skills, so while you're practicing this you're actually practicing loads of different algebra stuff, and algebra is something that quite a lot of students do struggle with. So to access this episode, we're going to need to know some things already, and these kind of things I will be talking around, but I'm not going to be teaching specifically. The first one is rearranging or solving linear equations. So for example, this type of question here. So solving 6x minus 2 equals 64. So if you want to have a go at that now, pause the video and just check that you can do that. Now if you can't do that, you might want to go and learn that somewhere else. Do let me know in the comments though if you want me to do a full-on video about solving equations. So I'll just briefly show how to do it, just to help you out. So first off, we're going to be adding 2 to both sides. So we get 6x equals 66. And then we want to divide both sides by 6. So x equals 11. So we're undoing each step as we're going down. So I'm not going to go into full detail on that. If you want a full episode on it, just leave us a comment. You will also need to know some operations with negatives. So you're going to need to know how to add and subtract negatives, how to times and divide negatives. So these type of questions here, just pause the video and check whether you can do those 4 types of questions. Let's have a check. So 8 subtract a negative 2. If you're subtracting a negative, that's the same as actually adding that number. So this is the same as 8 add 2, which is 10. 8 subtract 12, well, if we subtract 8 from 8, we get to 0. And then because we need to subtract 12, we've still got 4 more we need to subtract. So we get to negative 4. You may want to do a number line to help you out. So we started on 8, we went 8 down, and then we had 4 left over. So we got to negative 4 there. Negative 4 multiplied by 11. So we've got 11 lots of negative 4. So that's going to get me negative 44. And on this last example, negative 12 divided by negative 3. We've got a negative there, and we're seeing how many negatives fit into it. So it's a positive amount of negatives that fit into it. So that's just going to be a positive 4 and not a negative 4. So if you're unsure about any of that, really make sure you're secure on this before you go on to this video. And drop us a comment if you want us to go through it. So just to start us off with this topic, think about this equation here. So I've got an equation, y equals 2x plus 4. And if the question said, solve that equation, could you do it? Well, actually, with this equation, we can't solve it. We can't find just one solution, what y and x is going to be, because there's actually an infinite amount of different answers we could get. So, for example, if we said that x was, let's say, 2, this means 2 multiplied by 2, which is 4, and then we add 4 to get 8. So y would be equal to 8. So that's one possibility. But there's an infinite amount. I didn't have to choose x equals 2. I could have chosen anything. X equals 11, let's go for. 2 times 11 is 22. Then add 4, that gets me y is equal to 26. So you can see that it doesn't have to be one answer. And if you put this on a graph, if you think about the y-intercept and the gradient of this, the y-intercept is positive 4. So that goes up to there. That means that's where it's going to cross my y-axis. And my gradient is a positive 2. So if I go 1 across, I need to go 2 up. 1 across, 2 up. 1 across, 2 up. So we get this kind of line here. And this shows us that there's not just one answer to this. There's all these answers all along this line. So this is when x is 2, y is 8, x is 4. I think my line's a little bit off there. That should be y is 12. Should be a little bit higher. Just adjust that. I might have overshot it there. Something like that. That's a bit better. So you can see that this would actually carry on forever, and that's why I put this arrow on top here, just there. It looks a bit funny now because I've kind of skewed it, but that means it carries on forever. And let me just show you this on Desmos. So here is that graph, y equals 2x plus 4. So this is what I've just plotted here. And you can see what I did was just a very small amount of the entire graph. I only went up to 12 on y and 12 on x. So I only went across to 12 and up to 12. And actually it would have just carried on. And I can keep scrolling on this literally forever. I could zoom out as well, really getting some big numbers. And it's gone into standard form and it's just never going to end. And I could do this all day and I wouldn't get to the end of it, because that's why we can't solve it. It's got all those infinite amount of possibilities that could be x and y. So if we've got an equation like this, where we've got two variables, so one variable is my x, the other variable is my y. So I've got two variables, that means I can't solve it by itself. I can't find one solution for x and for y. There's an infinite amount. However, if I have two separate equations, for example, this, so I've got one equation there and another down here, now I can solve it because I've got two separate equations, different equations that have the variables in x and y. So if I've got two variables, I'm going to need two equations. If I've got three variables, I'm going to need three equations. So with our two variables here, I'll show you how to do it. I'll try and explain all my thinking alongside, and then I've got one for you to try afterwards. So having a look at this, we've got two equations, 5x plus 4y equals 30 and 2x plus 4y equals 24. And what you need to do is you need to try and get rid of one of those variables, either the x's or the y's. Because as I've said, we can't solve one of them by themselves if we've got two variables hanging around. So I'll show you how we can get rid of one of these variables. If I just draw a line under there, and I imagine that I'm subtracting all of this second equation away from the first. So imagine that's a subtraction. And let's think carefully about what's going on. I've got 5x's and I'm subtracting 2x's from it. Well, I'd then have 3x's left, wouldn't I? I've got 4y's here and I'm subtracting 4y's from it. So I'd end up with 0y's. Well, if it's 0 lots of y or 0 times y, that's just nothing. I don't need to include that. I'll erase it. Then there's my equal sign. And I've got 30 subtract 24. That gets me 6. So I've subtracted it all down, and you can see we have got an equation there that I can solve. It's just got one variable. There it is. It's just the x. So I can solve this now. And you can see all we need to do to solve it is undo that times by 3 by dividing both sides by 3. So I get x equals 2 as half of my answer. Because I'm solving it, I'm now found out what x has to be. But I also need to find out what y has to be. That's another part of solving it, because I need to find x and y. So what I'm going to do, I'm going to take my answer, x is 2, and I'm then going to use that to make one of these equations, whichever one, doesn't matter, into an equation I can solve with just one variable. So, which one should I choose? I don't think there's much difference between them really, it doesn't really matter. I suppose we could say that this one's got slightly smaller numbers, so we might find it a bit easier, but it doesn't really matter too much. So let's take this second one for argument's sake. I'll just copy this across. So there's my second equation. And I'm going to substitute in x equals 2. So where I've got x here, that is actually 2. So I've just found that out, right? So here I've got 2 lots of 2, so 2 times 2, plus my 4y, which is just there, and then equals 24. Lovely. I've now got an equation that has only one variable. It's only got the y in now, so I can solve it. So let's just do a little bit of working out here. 2 times 2, well that's 4. plus 4y equals 24. Then I'm just solving this, so I'm trying to find out what y is by undoing everything. Two options here. I could divide everything by 4, or I could take away 4. I'm actually going to take away 4. Get 4y equals, and divided that one, 20. And if 4y is 20, I need to divide both sides by 4. 20 divided by 4 gets me 5. So that's the other part of my answer. So I need the x and the y. So my answer is finding both of them. Right then, I've shown you that, and I want you to have a go at one now. So it's a very similar example. It's not too different. So it is this one here. So pause the video, write this down, and have a go at it yourself. Can't get it all, that's fine. You can come back and watch me go through it, or you can watch me go through part of it and then try your best from there. It's up to you. But I would recommend having a go before you actually watch me. Okay then, let's go through it. So I'm going to do the same as I did last time. I'm going to subtract. 9x subtract 2x gets me 7x's. 2y subtract 2y is 0y, so that's nothing. And I've got 58 subtract 16, that's going to be 42. So if 7x is 42, just need to solve that by dividing by 7. So that would get me 6. So my x is 6, that is half my answer. Then I've got to choose, what am I going to put that into? Which one? Well, this one does have lower numbers. We'll go for that one. Although it doesn't make a difference. If you went ahead and tried the other one, it would get you the exact same answer. We're going to substitute in. My x is 6, so this means 2 times 6 plus 2y is 16. Let's do a bit of working out. That's 12 plus 2y equals 16. And then I'm going to subtract 12 to undo this adding of 12 here. Subtract 12. So 2y is 4, so y is 2. All I've done there is divide both sides by 2. So you should have got x is 6 and y is 2. Remember, your answer needs 2 parts to it. Okie dokie. I'm going to slowly increase the difficulty here and increase the complexity. So that's the first example. It's kind of the simplest example you're going to get on a foundation paper. So let's have a look at example 2 here and spot what I've changed from the previous one. I've obviously changed the numbers, but I've changed something fundamental about the problem which changes the way we approach it. Wonder if you can spot it. Well, I'm not going to tell you just yet. What I'm going to do is just try the method we've just done. So we've just tried to subtract them. I'm going to see what happens. So 5x subtract 2x, well that's going to be 3x. I've then got negative 4y subtract 4y, and have a very careful think about that, thinking about your negatives. Negative 4y subtract 4y. Well, if I've got negative 4 and I'm taking away 4 from it, that will get me negative 8y. So negative 8y. And I think quite a few people, because they're used to that other method we've just done, might think, oh, well, this just makes 0. But if you think about it carefully, it doesn't. It makes negative 8y. 23 subtract 26 is negative 3. And look what we're left with. We are left with an equation just like these ones. I've got 2 variables still. I've still got x's, I've still got y's, and I can't solve it. So this hasn't helped me. So we need to try something different this time. And the different thing is, instead of subtracting to cancel out a variable, I'm going to try adding to to cancel out a variable. So let's have a careful think about this then instead. 5x plus 2x, that gets me 7x. Negative 4y, it's helpful to write these negatives on the side. So negative 4y plus 4y, so plus a positive 4y. That gets me 0, because I'm on negative 4, I'm adding 4 to it, I'm back to 0. So that will get me nothing there. And 23 add 26 will get me 49. Now look what I've got. I've got an equation, but only one variable. I've only got the x, I've cancelled out the y. Wonderful. That means I can progress. So if you make a mistake in an exam, you do the wrong thing, you're left with a y and with an x, hopefully you'll be able to recognize that. It's not the end of the world. You can just try the opposite. So it is good to be able to spot when you use one and when you use the other, and you'll get that with time, practice. But really, if you go wrong, if you're being careful and thoughtful about what calculations you're actually doing and being mathematical about it, you can't go far wrong. You'll just spot your mistake, go back and sort it. So 7x is 49, so I divide by 7, which will get me x equals 7. So that's my x. I'm then going to substitute that in. Now this time, I'm probably going to choose this bottom one here because I don't want to have to deal with this negative. I could do, I'm pretty good with my negatives, so I could probably deal with it. However, I'm going to try and avoid negatives if I can, just because it means that I'm less likely to make a mistake. So let us paste this one over here. This here, I'm going to replace with 7. I'm going to substitute that in. So I've got 2 times 7 plus 4y equals 26. 2 times 7 is 14 plus 4y equals 26. And then I'm just solving it like normal. So for me, it makes most sense to subtract 14 from both sides first, which would get me 4y, because this has vanished over here. This has been cancelled out by the takeaway 14. 4y is 12, and then I can divide by 4 to find y equals 3. So that is the second part of my answer. So it wasn't too much different. All I was doing, I was adding instead of subtracting, and the reason I was adding was because I tried the other one, it didn't work. But if we look at the structure of this question, these bits that are the same, which is the bit that's going to cancel out, so I've got the coefficient of 4 before both of these. One's a negative and one's a positive. So that was the situation where I was going to add, while in this one, they were both positives. So that's the situation where I would subtract. So have a look at this example here now. So I've got a similar structured question to the previous one. And I want you to pause this video and have a go. Okay, let's see how you got on. So with this one, first of all, I've got this x here, and just in case you don't know, an x by itself is just one lot of x, so 1 times x. If that's where you got stuck, just go and retry it now. We've got a positive 8y here and a negative 8y, which means that I'm going to be adding these together, unlike the subtraction. Because these signs are different, they're opposites, I'm going to add them together, and that's going to cancel them out. So I get 6 x's, this makes 0, they cancel out, and 43 plus 23 makes 66. Well, if 6x is 66, then one of those x's has to be 11. And we get this 11, part of our answer, and we're going to substitute that into one of our choosing. I'm going to go for this top one, since I can avoid the negatives that way. And let's replace our x here with 11. 1 times 11 is just 11, plus 8y equals 43. So 8y equals, we're going to take away 11 from both sides. That will be 32. So y equals, if I divide by 8 to both sides, that will be 4. So that is my full answer there. X is 11 and y is 4. So I've got the 2 parts of the answer. Okay, I will call that it. This is about time for this video. In the next video of this deep dive, we're going to be looking at some other situations you might get on simultaneous equations questions. We're going to have a look at ones where you get the same sign but they're both negatives. We're also going to look at ones where you don't have a matching coefficient, because if you look at this, I had 8y and 8y, even though it was positive and negative, 4y, 4y, 2y, 2y, 4y, 4y, so they were all the same number. And that's because I've tried to keep it simple, going through the simplest examples first, but we're going to have a look at the more complicated ones where that's not the case and we need to alter it.